The recorded session will be there on our site, so it will be available.
Okay.
People can always go back and watch it anytime.
Yeah, recording started.
Okay, so yeah, you can get started, Vigneraj first, and then
Okay.
I'll add few comments.
Sure. Thank you. Welcome, Sunil, and welcome everyone for another wonderful knowledge sharing webinar by IEEE ComSoc Bangalore chapter. So today's topic is really interesting one, which is on private 5G enterprise use cases, deployment models, and challenges. The speaker of today's webinar is a truly experienced and hands-on person, Mr. Sunil Pareek from Cisco. Mr. Sunil has more than 15 years of hardcore experience in network design and implementation, especially in service provider environment. He is focused on design and deployment of large-scale CSP and enterprise networks, customer transformation towards 5G, software-defined next-gen networks, etc. Sunil invests a lot of his time in educating customers, partners on latest service provider and enterprise core technologies, including 5G transport, SDN, virtualization, and so on. He has presented at various forums and has published several white papers in service provider networking domain. He also holds active CCIE certification in routing, switching, and service provider since 2011. Welcome, Sunil. Ganesan sir, if you want to add anything.
Yeah, welcome everyone for this first technical talk in the month of March. Myself, Ganeshan Tyagarajan, Chair of Communication Society, Bangalore. We have been conducting several such technical sessions, short 1 hour webinars kind of thing on almost twice in a month, sometimes even thrice in a month. So we usually have one technical talk on the first Saturday of every month and the third Saturday of every month. So that we have been doing, and please join our Telegram channel for getting this information, and also the IEEE notice this information is getting posted. We also publicize in LinkedIn channel. So we have been arranging many technical talks, like this private 5G is one of such talks. Last week we had something on last fortnight we had artificial intelligence and video analytics for smart cities. Then we had one on green computing and edge computing. These are all like a few samples of the talk that I have been done this year. So this was first DLT for this year done by Professor Melike, a well-known person in the area of deep and reinforcement learning, especially in the communication application. So we pick up variety of cutting-edge topics, and this topic is one of such kind. And the focus is mainly make it simpler enough for students to understand the fundamentals. And at the same time, this is also there is something new for the professionals to pick up, or the young professionals who are aspiring in this area. Like this, ComSoc have been arranging a lot of webinars, and we also going to arrange half-day workshops in detail, deep dive sessions. Watch out for the notices in the social networks, as well as in our ComSoc page and in the Telegram channel. As Dr. Pingaraj mentioned, Sunil Pareek is one of the well-known person working in this 5G area, and we are looking forward learning from his knowledge. And with that, I give the podium to Sunil. Thanks, Sunil, for accepting our invitation. Please go ahead.
Yeah, thanks a lot, Ganesh and Pingraj, for such a nice introduction. It's a pleasure to present on this forum, and all thanks to you, Subhash and Ringraj, to give me this opportunity to come and talk about this exciting topic that I am currently investing most of my time these days. So without further delay, let me just share the presentation that I have, and then we can start talking about it. Um, so, first of all, thanks a lot to all the participants who have taken time on their Saturday evening joining this tech talk. And I will make every effort to make this talk useful for you. The way this talk is organized, there are some information that you may find repeated, but there is well intent behind that, because important information, if it gets repeated, it's a clear key takeaway for us to get when we go out of the meeting. So that was my intent. Uh, Title for the talk today is Private 5G for the Enterprise. As you see, there are two words, 5G and enterprise. When we talk about 5G, the things that come into the mind is primarily the cellular world, the service providers, how they are implementing. But in this talk, we are not focusing on any of that stuff. I will not go into how the 5G architecture work, how this cellular communication or the workflow work. And then the second word is enterprise. So I will also not cover the network architecture of enterprises or what the enterprises are all about. What we will cover is the next gen enterprises, what they are demanding, and how 5G is fulfilling those use cases. So basically, what are the use cases where enterprises should care about private 5G? What are the business advantages for the enterprises to go and consider private 5G as one of the potential deployment? And what had changed recently in these enterprises that is also the focus for our talk. So this is mainly we will be focusing on the why part of it, why enterprises should consider private 5G. Then we will get for a brief amount of time into what private 5G is. And then towards the end, we will spend some time about, on the private 5G how part, how enterprises can consume this private 5G. I will be taking some pauses in between if there are any questions. So to start with, why an enterprise should consider private 5G. And if you look at the next gen enterprises, the demands from the networks are ever increasing. They want the deterministic network performance for their business critical use cases. They want secure network, private network, reliable network, and the list goes on. And it did just happen that sometime back, I was pulled into a discussion where uh, it was a simple, plain enterprise architecture discussion with a customer that was going on. And I was asked to like present the technical side of it to understand customers' technical requirement and then maybe propose a solution. And when I got into the meeting, I thought it's like something that is the standard enterprise design that we have done for ages. And even the customer have started with the the normal use cases where they asked for a reliable network, their bandwidth demands, their latency, and all that general network parameters. Then suddenly, what happened? There was this one principal architect. He jumped in and he said that whatever we are talking, uh, it is for our site, and that site is actually a mining site. So it's somewhere remote in US where there is no reliable network coverage. But the network they are using currently is not reliable at all, and it is not present at all the parts of this site. It is actually a 5 miles side by side uh, site, and what they are looking at is a reliable network. And one of the use case that got stuck in my mind during that discussion is this guy said that earlier in the past there were 2 to 3 people who used to work together in the mining site, and if something happens to one person, any accident, or if he fell down or something, there are other people nearby to help him out. Now what we are looking at is to offload this to the network. And what he meant by that is that they want to have some sensors on these persons, and if these sensors detect some unusual behavior, or if the person fell down, then the sensor should get some notification or send it to the central system. And then immediately their emergency response system will be activated and they will go and rescue the person. So you see here, the network that they want is also used to save the lives of the people. It's that critical, and that's where they say that, you know, that's where, or that's what our demand is from a reliable network. So basically, the thought process behind covering this story is the next gen enterprise wireless needs are changing.
Sunil,
Networks are
can I interrupt? Can I ask one question?
yeah, please.
Yeah, so see the private network already, if you are talking about mines or anything, they already have some kind of existing network, something maybe custom made or proprietary, some means of networking solution they're already using it, either wired or wireless, different solutions people have come up with. Why do
Right.
they think by going to a private 5G standard compliant solution that all their existing current problems will be solved? Why they think that going for a private 5G network will help to solve the problem better?
So, so private 5G, it's just a dedicated network for that particular enterprise, you know. And 5G, as we see that it's promise is three promises basically it fulfill. One is the enhanced mobile broadband, then ultra low reliable latency, and then massive machine-to-machine communication. Today, if we look at the network, it is no more about the user talking to the machines, or like it's Ganeshan coming in the office and doing something. It is also about machine to machine, where there are very stringent demands in terms of latency. There are ways exist, like for example, as you said, wired network, but wired network comes with its own cost. There is a significant amount of dollars investment goes if you want to cover a particular area with a wired network. If you look at the Wi-Fi, yes, Wi-Fi exists. It's another alternative, but that is an unlicensed spectrum, and there are a lot of interference issues that happens. There are a lot of black spots that happens, and to mitigate all these things, there is this another alternative that is coming into the picture is private 5G. So where 5G will be used for the enterprises, and they will have different ways to consume it. We will cover that part.
Okay, but they'll be using different frequency band, or they still use the same 5G bands only?
So yeah, so that also goes. It depends. They can. So there are certain countries which have reserved some of the spectrum for private enterprise use. So for example, in Germany, there is a particular spectrum band that has been reserved for any enterprise, they can come and consume it. In US, if we talk about, there is a CBRS band that these enterprises can consume. That is one way of consuming it. Or these enterprises can also reach out to the service providers where they can ask or they can lease some of the spectrum from the service provider, and it's basically a business for service provider where they can lease something to this enterprise and get some business out of it. So that is another way of doing it.
Okay.
Yeah, I have some dedicated slides on this, like how enterprises can consume private 5G.
Okay, thank you. Sorry for interrupting.
No problem. Yeah, feel free, please. So as I was talking about these next-gen enterprises, what are the demands that we were focusing, right? Those are changing. So earlier it was like simple information sharing, or the interface between the network was user to machine or user to user. And but now if you look at it, there are AR, VRs or streaming video at 4K or even 8K is a norm. If you look at IoTs, IoT sensors are there for quite some time now, but then we are talking about lighting, badge, vending machines, X-rays, or even automated guided vehicles. They are also using this network. Or the wireless, as we have seen, it has evolved from Wi-Fi 6, then 4G or even 5G now that we are talking, or the focus for this talk. So the purpose or the intent behind this is that from the network, user expect the experience. And IoT is the new norm. We cannot ignore it. So the point is that we are now much more dependent on the network than ever before. And the applications, as we talked in the mining examples, are very critical. So the reliable network is no more an optional ask. There are, very critical business use cases behind it. If we look at different type of industries, you name anything, I have some of them listed here. Oil and gas, mining, I was talking, supporting venues or healthcare. They all have these critical use cases where like if we talk about supporting venues, the security cameras are a need, or if we talk about any automobile industries, automated guided vehicles are using the network. Or as you see, I don't need to go through each and every use case. So these are like clear healthcare where surgeries are being performed remotely. So just think like how critical the network is in those use cases. And one thing that comes from this private network, basically the requirement is that enterprises are expecting one is the isolation from the public network, basically. So where due to different reasons, like security is one of them, data privacy is another one, or they expect lower latency. The latency that we are talking here for machine-to-machine communication is anywhere in the magnitude of 1 millisecond to 5 millisecond, and that is possible with 5G. There may be a question here that, okay, can't we go with public 5G? Yes, and you or an enterprise can go with public 5G, but in our experience, what we have seen that they don't want any reliance on cellular operators. They want to have their own network and stringent SLAs and the business use cases are there to back this claim where enterprises are looking for private 5G. So I'm using this term private 5G, but what is the difference basically? If I talk about the public network versus private network, let's spend some time by looking at what are the differences between these. So one obvious difference is the spectrum. Basically, in case of public 5G or even it is 4G, the spectrum is owned by the carrier. But when it comes to private 5G, there are different models that exist. If a enterprise is big enough, it can own a spectrum, or it can use some shared spectrum as well. Or as I was talking to Ganeshan earlier, it can obtain or lease some spectrum from the carrier. So there are different ways where enterprise can consume the spectrum. And one of the key enabler for private 5G, in fact, earlier, if we talk about previous generations of the cellular network, getting the spectrum for an enterprise was a bit difficult task. It was only the operators who goes into the auction and they were getting it. But now countries or some governments are reserving some spectrum just for private use, and enterprises can consume it. If you look at use cases, so for the public network, consumers like you and me are the primary consumers, but for private network, it is the enterprise, which is the main consumer. If you look at infrastructure or data, it is owned by the carrier in case of public 5G, but enterprise is the owner if we come on the private side of it. If we look at the management, public network are managed, of course, by carrier, but private 5G, there are again different models that exist. So either it can be managed by the enterprise. If the enterprise is big enough, if they have all the expertise that is needed, they can manage this enterprise network, or they can go to the SP and take SP's service provider. When I say SP, I mean service provider like Airtel, Reliance, if we talk about India, they can go to these service providers and take their help in managing this 5G, private 5G network. And service providers are the one who are managing their own network, so they don't have any problem in extending that management to private 5G. And in fact, it is a big business use case for them. Or the third option is the vendors like Cisco or any other vendors in the market. They can also help them to manage it. So these are the differences at high level between public and private network. And whatever we have discussed so far in the last 10 minutes, if I need to list it down into some bullet points and describe some reasons why or what we have discussed. So one of them was this consistent, reliable coverage that enterprises are looking. And private 5G is one of the options that is offering them. Second is, as it is not only the users who are talking to the network, it is the machine-to-machine communication, and that expect ultra low latency for these time-sensitive operations. The third one is the faster handoff. For example, an automated guided vehicle in a automobile manufacturing industry, it needs faster handoff, and that is much more reliable and network oriented if we talk about 5G or cellular infrastructure. Extended coverage, cellular networks are known for their extended coverage. We have these different bands, low, mid, or MM waves. If we leave the MM waves, basically the low or the mid band of the spectrum can have this wider range, or if you look at the 4G side of it, even that have this wide coverage. And the last and the most important out of all these is the cleaner spectrum. If you go with the Wi-Fi, that spectrum is unlicensed. But with 5G, you have an option of getting a licensed spectrum, and that licensed spectrum can be used for critical applications. So we have seen use cases where enterprises are using shared spectrum as well as this leased licensed spectrum, and they are running their critical applications on the licensed one, and for other purpose they are using this shared spectrum. That way they get a wider pipe basically for the UE, and they get their critical applications don't get disturbed because it is running on the licensed spectrum, uh, and in case of their any interference. So hopefully by now I'm able to convince you that, okay, there is a clear cut use cases for private 5G in the enterprise world. And believe me, for 5G, if we look at, one of the difference that I see between 4G and 5G, for 4G, the biggest consumer were the people like you and me. When we all went online, browsing for hours and hours on our cell phone, streaming videos without any buffering. But with 5G, it will be the enterprises from where the main business for the service provider will come. So enterprises will be the biggest consumer of private 5G in one form or other for the service providers. So I will take a pause before we move to the next section. What is private 5G? So any questions?
Yeah, I have a couple of questions.
Yes, sir, please.
So see, I see there is a value definitely going for 5G, but this also comes with an additional investment. For example, earlier the cellular provider, service provider was giving you the all the infrastructure needed. He takes care of the investment in getting the infrastructure. Now you are going to incur that cost in your premises. That is one. Second thing, the earlier the spectrum was shared by everyone. So the cost of the spectrum was evenly spread out across multiple consumers. So now you are going to pay for that specific spectrum that you are reserving or even buying from the government. Third, security problem. Since people know that you are using this particular band, somebody can come as a deliberate jammer in that frequency to give a denial of service attack, right? So you are susceptible to higher cost. Then you have to maintain the infrastructure. So there is also maintenance cost. I mean, in terms of software upgrade, features upgrade, everything, and at the same, and also the security loophole that we are providing, because it's going to be a particular band that you are going to use. So despite all these disadvantages, still the world is going towards enterprises are going towards private 5G. Why?
So, yeah, the concerns that you have highlighted are very much valid, and that was in fact one of the key reason that private 5G deployment provide you a lot of flexibility. We will cover it in the upcoming slides in the how part of our private 5G consumptions, but the model is very much flexible. If for example, I was giving that example of a mining industry, when we discussed with them that, okay, there are different models of consuming private 5G, and one of them is that you can use the shared spectrum, but then there are chances of interference. But then it was a point which was like very remotely located. They own that area. There is nobody around it. So they were fine. They said that we will not face this interference problem because we are very remote and there is no other provider or there is no other network or any nearby stuff that can cause such type of interference. But Yes, I agree with you that in certain cases, interference or these things are a norm. That's where these enterprises also have the flexibility of going to a service provider and lease some of the spectrum for their use. Where service provider is responsible for all the management, enterprises are just acting as a consumer for it. And when I look at your third point, the cost basically, so there, how I look at it is there are two costs associated with it. One is the capex where you deploy your network initially, leasing the spectrum from an operator or from an government agencies, deploying your RAN infrastructure, then the packet core, everything. But then the major part is how you will operate it. So the operation is also contribute a lot into the cost. And currently what we have seen in enterprises, they are good with wireless. They are good with managing their wired network, but they have no clue on managing the cellular infrastructure. So this technology is completely new for them. So that's where again the service providers come into the picture where they offer a helping hand, or the vendors like Cisco or some system integrators who take the responsibility of managing the network. So basically enterprise can outsource that part to these and enterprise don't need to worry about any of these challenges. So I would say the flexibility that it offers, help the enterprise to mitigate the challenges. Does that answer, Mr. Ganeshan?
Yeah. Thank you. Yeah.
Yeah. Okay. Any other questions before we move on?
I have a question, Vigneraj here, Sunil.
Yeah,
S-
please.
You mentioned one thing that for a for enterprises such as oil and gas or mining, typically their sites are very remote. So in case a private 5G, how does the transport thing or the backhaul thing will be taken care of? Because if the fiber is not laid down till the sites, then how does that be handled in typical scenarios?
So, yeah, again, a very good question. Thanks, Pringaraj, for asking it. There are two cases here. One is all their critical applications are hosted locally. And what they need is the utmost reliable connections only to those applications. And that's what this 5G is providing. Then there can be an unreliable connection to the outside world because that is not their main intent. Other thing is where there is a need to communicate with the outside world. It can be a fiber or it can be some sort of SD-WAN link as well that can be over an internet, uh, or any IPsec tunnel or anything to fulfill that transport.
Okay, thank you.
Yeah. Okay, thank you. Thanks for the questions. So moving on, introduction to 5G. So now that we have covered the why part of it, now let's just look at quickly what private 5G is. And this we all know that every 10 years there is this new generation, and it was started with 1G, 2G, 3G is when people have started it noticing, that time, at least in India, cell phones were not that readily available commodity. So it was still with very few set of people. 3G is when most of the people, I would say some of the people have started using it. And when Geo came around 2016 time frame, that's when people become the mass user, and it was 4G. That was the primary connectivity that was available at that time, and we all went online. And now we are talking about 5G. So clearly there is a difference, like from user experience to connected experience, what 5G is offer. There are many use cases for the enterprise that we have discussed. And how does the private 5G basically fits into the enterprise world? I normally present these slides to the enterprise folks, and they, as I was saying, are not aware like what a cellular infrastructure look like. So I try to compare this with the traditional enterprise Wi-Fi architecture. So where there is a Wi-Fi access point to broadcast the SSIDs, and then we have the central piece, which is WLC, which is wireless LAN controller, which is responsible for managing the APs. And again, I am covering it from a high level. We are not going in depth. That's not the purpose for this talk. It is just to explain you the similarities, or what Wi-Fi is, or how 5G looks like. So this WLC is basically when a user comes online, they try to log in into the user network, they has to authenticate themselves. So there is a ICE piece, the AAA that is used for authentication. And backend can be Active Directories. So this user get authenticated. Once they are authenticated, then this policy engine comes into the picture, who dictate like what they are allowed to do into the network. So there is this authentication piece, and then there is this authorization piece, like what and what part of the network they are allowed to communicate. Same way, if you look on the 5G part, let's just replace whatever you see in the dark green on the slide with the some of the cellular components. So instead of WLC, ICE, AAA, we have these cellular components which are like AMF, SMF, UPF. All these are cellular terminology. You don't need to like understand it deeply to get the gist out of this tech talk. But if any of you are interested, there are lots of YouTube videos around this. But the point here is the authentication and the authorization that was done on the previous slide by WLC and ICE. Now it is the responsibility of the AMF, along with this AAA and the UDM that you see on the slide. And then the policy function is performed by the PCF. So from the 30,000 feet view, I can see some similarities between the two. Yes, though the working is different, the protocols are different, the components are different, but more or less it performs the same thing. So this is basically the architecture high level for 5G in an enterprise. And there are three pieces of 5G or private 5G when an enterprise consumes it. So before I go into those three pieces, let me start with the definition. Like as per 3GPP, it is a standard body for 5G. A private 5G network is dedicated to carrying traffic for a specific entity. It can be a public sector agency, or it can be an enterprise. And so what I was saying, there are three pieces, and one of them is this UE, as you see here on the slide. This UE is the user equipment, and it's not only cell phone. As you see, there are multiple devices listed here. So these are the UEs. Then there is this RAN part, which is radio access network, and then the mobility core part. Is what make a private 5G infrastructure for an enterprise. And to bring us questions, there is a transport in between, as you see here. This transport can be any fiber, or it can be any internet link with some SD-WAN or IPsec enabled on that part. And then we have the spectrum as well. So during the start of this talk, I was saying that private 5G gives you a lot more flexibility. And one key takeaway that you can take from this presentation is when you deploy this network, it's mainly drilled down to how you deploy the RAN and how you deploy the mobile core network. RAN obviously has to be local at the site. You can have this core component at the site, or you can have the core component back in the cloud as well. So depending on the placement of this mobility core component, there are different models, basically how you deploy the network, and we will cover it. But before I go on to these, any questions here? Okay. So I will cover this private mobility solution models, as I was saying. So one is the technology choice. You can go with 4G, or you can go with 5G also when we talk about private networks. It clearly depends on the use cases. If your use cases are too rigorous, they need some millisecond of latencies, high network bandwidth, probably 5G is the choice. And then the second point is the placement choice. Basically, where exactly you want to place the component, as I was showing in the previous slide. It can be on-prem, everything is hosted in that enterprise, or some of the components can be pulled into the cloud. And then the acquisition, as Ganeshan had also asked, how enterprise want to consume it. They can help or take help from the vendors like Cisco or any other company. They can go through any service provider as well, or they can directly consume it. It's up to the enterprise. Depending on this, there are 4 deployment models. It's like for private LTE, if I look at, there is the CBRS. So CBRS is nothing but just citizen band radio services. It's a spectrum type of shared spectrum available in US. Enterprises can use this spectrum basically. Likewise, there in some of the countries, there are some shared and dedicated spectrum which are available for consumptions, and other countries maybe follow the same going forward. So one model is where you have the CBRS spectrum, you are consuming it, and everything is on-prem. When I say full stack on-prem, means your RAN is on-prem and your mobility core component is on-prem. If you take the mobility core component and put them in some cloud, for example, let's say you have multiple enterprise sites. You don't want to put all the components on every site. You can put them at a centralized location like a cloud, or maybe in service provider core network somewhere, and the RAN obviously will be there on the site. So that is the another model. Same way it goes for private 5G as well. So private 5G, either the full stack can be on-prem or it can be a cloud hosted solution as well. I hope this is clear. So depending on all this, what we have discussed so far, there are actually 5 different deployment models. As I was saying, it gives you full-fledged flexibility when you deploy private 5G. So here you see in all the models from 0 to 5, it is actually 6, but you can ignore model 0 because that's where everything is owned by the carrier. So from model 1 to 5, you see there is a red part and then there is a green part. So the red part is basically managed as a service from the operator, or it's in the cloud. And the green part is what is owned by the enterprise. So what we see here is the model 0, that is basically a commercial offering from these public 5G operators going forward. That can be extended to the enterprise where they can use the public network. But if they want to go with private, then we have this model 1 to 5. And currently in our conversation, what we see is majority of the customers are focused on model 4 or 5, where everything from the radio, the data, the control plane, subscriber management, either the enterprise itself is responsible for managing it, or maybe some sort of management they are offloading to the cloud vendors or the service provider operators. Then this model 3 is also getting a lot of tractions where the management and the subscriber management is moved into the cloud. And rest of the piece, the control data and radio are in the locally to the enterprise. One more thing that I want to highlight here is, and we will cover it briefly in the upcoming section as well, while there are different models that exist, it gives us a lot of flexibility, but going with one model versus other also have some use cases. For example, if I go with model 1 and 2, if I look here in model 1 and 2, in model 1, only the radio is there on the site. Rest, all the components are there in the cloud. But if you or if a particular enterprise have certain applications which demands very low latency, let's say 1 millisecond to 5 millisecond of latency, then it is advisable that they have this data component also locally present on the site. Because if it is present in the remotely somewhere in the cloud or in operator, then you can't meet those rigorous latency demands. So one side, yes, there are flexibilities that you see across these models, but then there are use cases also. So we need to understand what the use cases are for particular enterprise and then choose what is best for them. I hope that makes sense. Now let's look at these models that we have covered from the network perspective. Basically, how does the deployment looks like? So you see this typical enterprise where there is a SIM card, there are some 4G devices, the radio, then there is this LTE core, and then we have these subscriber services. So in this case, if the enterprise is fully owning it, they can take the SIM card from the service providers because enterprise cannot manufacture SIM cards. The SP's responsibility, but then they are responsible for managing it. So going forward, in each of these pieces that you see here, the core, the RAN, the subscriber management, everything is enterprise owned as well as enterprise managed. Whereas another flexibility that we have talked about is the operator assisted. In that case, it can take some help from the service provider, where some of the components, as you see on the slide, are owned by the enterprise, but then there are some network functions or components that can be SP provided and SP managed as well. So that way they share the responsibility basically. So this way they can go with, and mainly what we see is the option B that most of the enterprises are choosing, where they want a service provider to manage their network. If we look at the RAN side of it, the RAN basically, there are two factors. One is the licensed spectrum. Another one is the shared spectrum. So, and as you see on the slide, there is the enterprise network that have the shared spectrum as well as the licensed one. And then there is this operator who can also have its own licensed spectrum, and it can also use the shared spectrum to basically service the enterprise. So they both can go with this type of RAN model for the enterprise. If the enterprise want to go on its own, it can use something called as carrier aggregation, where it can use both the spectrum, licensed one as well as the shared one, and can have this wide band for the UEs, and some of the critical applications can work on the licensed spectrum. The other piece that you see here is the PLMN. So PLMN is basically on a term on the mobility side, where if I want to give you some example, let's say today, if you are turning off your cell phone and you have this Airtel SIM, so that SIM is programmed to connect to the Airtel network. Or for example, my phone, it's programmed to connect to the Vodafone network. So that is what the PLMN is. It just like connect to that operator's network. So the enterprise PLMN, it can be programmed, either it can connect to the enterprise core network if everything is hosted locally, or it can be connect to the operator core network as well, where operator, and this is very important, where operator is sharing the core with multiple enterprises. And that's what we call as MOCN, the multi-operator core network. So an operator can share its core network with multiple enterprises. And if there is a use case where a UE who is registered on this license spectrum that we see on the green side on the enterprise need to connect to operators network, they have this interface between the enterprise core network and the operator network, where they can connect. And this is basically nothing new here. It is called as roaming. So if I have not done a good job in explaining the previous slide, let me explain it here. So this is one model for the RAN where you are using the shared spectrum for an enterprise, and that is connected to the enterprise core network. So that is one model. Second one is where you have some licensed spectrum as well, and as well as the shared spectrum, but you are hosting your core locally. That is the second model. The third one is where you have this multi-operator core network, where you are also registering with the enterprise core network as well as the operator's core network. So these are the three RAN operating model. And now we come to the final piece of it, which is the core network. So the packet core network, as you see on this slide here, what you see here is deployed on the enterprise customer premises. And then we have this IPsec tunnel, and all these components here are hosted in the cloud. So this is like you have only the radios on-prem and everything is there in the cloud. Whereas another deployment option can be, or as I was saying, right, there is a latency demands, you can have the data plane component also on site and still having some of the components in the cloud. And then there can be a management. It can be the customer who is managing this, or it can be the operator who is managing this whole network. But the idea is, if you want ultra low reliable latency, then you need to have the data plane components at the site. And we have discussed it, couple of these models. Everything is valid, but it depends on the use cases, like what you want to achieve out of the network. And all these consumption
One question, Sunil, here. Is there any model where similar to the integration of CBRS radio spectrum and the operator spectrum, anyone have tried the operator spectrum and the Wi-Fi services inside the private Wi-Fi?
Yeah, so yes, Wi-Fi is, so what we have seen so far is Wi-Fi is mainly for the carpet areas, office carpet areas. Wi-Fi is still predominantly used. And when you come out and you talk about these manufacturing or these OT side of the network is where private 5G is used. And both can coexist together.
No, there is also the service integration. For example, if you look at the 5G core network, they do allow non-3GPP data to be coming and merging at the core network level, where it goes to the internet or any other services, right? So there is some level amalgamation is happening at the core network, not at the RAN level though. Yeah.
Right. Yes. I agree. Yes, there are certain, like, yes, there is some aggregation happening at the core layer as well. Right. Yes.
Thank you.
Since we are over time, I will just take few more minutes to cover this, and this is the last slide. So all these consumption models that we have talked about, it actually depends mainly on the spectrum as well. Whether there is a spectrum available for use. Some of the countries, as you see listed on the slide, Germany, UK, France, they have some spectrum reserved for it, and then there is some shared spectrum that give you the flexibility of deploying on-prem or with the help of SP, independent private network. If the spectrum is not available, for example, in some of the countries it is not there, then you have the option of going with the service provider, where service provider lease some of the spectrum and then they manage the network on your behalf. So this is what I want to end my talk with, the private 5G, as we have seen lots and lots of use cases, next gen networks, stringent demands. For that, some new investment need to be made, and private 5G is a potential deployment option that can help, but it will coexist. Wi-Fi is not going anywhere. Wi-Fi will stay for some time, at least a significant amount of time, along with Wi-Fi 5G. And the things that need to consider are UE availability, spectrum availability, how you manage the solution. So that's are some of the factors that need to be considered. With that, I'm done. Are there any more questions?
Yeah, thanks, Sunil. I think it's a very wonderful presentation of covering all aspects of private 5G. Yeah, now the floor is open for questions.
Just a quick question, Sunil. Ignorance here. So,
Yes.
are there any comparison study done on the cost part of it, depending on whether the deployment, private deployment, is small scale or a large scale? Where you mentioned like on-prem components, RAN core, etc., versus cloud components. So, are there any specific study on the cost part of it, so that anyone can have a look of that if you have come across?
Well, I'm not aware of any ready-made study as such, but it depends on the use cases as well that we have seen and how much pain an enterprise wants to take, basically. Sometimes, yes, cost is one of the key factor that we consider, but then, managing such infrastructure is also another key thing. So if the cost is less, but then the pain is more. Definitely, enterprises are looking, okay, let's get rid of it and just focus on our core business. And there are vendors like Cisco or other operators who are there to take care of that for us. Any dollar comparison or something, I haven't seen.
Thank you.
Hey Sunil, great talk. Can I just compliment your answer to Bignoraj? What you
I
just
was
mentioned?
about to ask that, Subodh. I just saw that. Okay, so you are there. Yes, please go ahead and comment here.
It was tempting enough since you skirted all the technological pillars, right? So Bignoraj, I think the way we're looking at, I'm just taking a case in point. If you take financial services, right? So I mean retail banks, insurance, stock exchanges, and fiduciaries. They are looking at this more like a transformation exercise, right? So if they had a network which was basically just connecting, let's say 10 users like us who are always on the field, and imagine 200 users who sit in the offices. Now suddenly the Wi-Fi and the private 5G, both of them complementing each other, and the way Sunil explained, that becomes a very, very unique productivity option, because it enables you seamless operation. Whether you step inside the bank premises where you are on the Wi-Fi 6, and you get the same benefits, right? Because we both know from a spectrum, clean radio perspective, and most important from a reliability perspective, both these technologies score. So, and thus every vendor, it's not just Cisco, but every vendor will have certain unique points. But we believe strongly that it is going to really herald a major shift. I think even if I just take again the same pillar, financial services, they will move beyond the e-kiosks, the ATMs, and the wallets. They will really go to the next level. And most of the things which we really read just in value-added or value chains will now be a reality for this banking services. So if you're keen, you're welcome to check out our solutions page, right? So we kind of believe this 5 sectors, so banking, healthcare, energy, manufacturing, and smart/sustainable communities, they will all be impacted by this. It's just the next evolution for massive IoT as well. So let me know if you need the URL. I'll be more than happy to place it, man. Absolutely, beginner Raj. And great question.
Thank you, Subodh.
Yeah. Great talk, Sunil. I got to say, very nice. I missed the first 15 minutes, but was very, very happy and nice to see you again propound exactly the same way as you do it for our customers. Thank you so much.
Thank you. Thanks so much for dialing in.
So thank you, Sunil, for a wonderful talk. If there are no further questions, I would request Mr. Subhas to give a vote of thanks.
Thank you. I was listening from the beginning, so you have covered a lot of.
Subhas sir, your audio is too feeble. If you can just speak a bit louder.
Just a shade louder, Subhash. Yeah.
Is it better now?
It's still slightly feeble. Slightly feeble for me, at least. Just a few notches higher.
Yeah,
It
just
is still low, yeah.
Yeah, a bit more harder, yeah.
Is it better now?
Oh yes,
now
Subhash.
it is
Loud
fine.
and clear.
Yes.
Okay, sorry about it. Was my setting, so I realized that setting auto adjusted to a low volume. So yeah, thanks Sunil for taking time out in a weekend and being proactive, offering to make a presentation for the benefit of the members and non-members, all those who are following IEEE Communication Society Bangalore. So it has been a wonderful talk. Many of them have already talked about it. So you covered many cases, very practical cases, what customer is looking for, what 5G can offer, what are the spectrum options, the deployment options on the RAN, core, on-prem, SP hosted, control in cloud, MOCN, and so on. So it has been great to hear from you. We look forward to your continued association, and hopefully you will continue into the thriving ecosystem of ComSoc Bangalore.
Yeah,
Thank
sure,
you again.
definitely. I would glad to. Yeah. Thank you so much, Subhash and team and participants for joining. I appreciate.
And Vignesh, thank you for hosting the event. All right, we'll see you soon again. Goodbye.
Thank you. Bye-bye.
Thank you, everyone.
Thanks, ComSoc team. Thanks, Sunil. Cheers.
Thank you.